Let's look at the graph of y equals 2 to the x. We say that the two fundamental points that define this exponential function, the graph of this exponential function, are the y-intercept and the x equals 1 point. The y-intercept, of course, is obtained by substituting 0 for x. We get y equals 1, so we have the point 0, 1. If we substitute y equals 1, of course, we get x equals 1, we get y equals 2 to the 1, which is just 2, so we have the point 1, 2. And these will be taken as the two fundamental points of the graph. Having those two fundamental points, we can easily sketch a graph that goes through those points and has the basic shape of an exponential function. Now, by contrast, let's look at the graph of y equals 1.5 to the x. On this graph, where we've incidentally graphed y equals 2 to the x as a dotted red line, and I think in your notes I mistakenly thought that we had an arrow here somehow, so I said something about that, but everything looks okay here. In any case, we've got the y equals 2 to the x graph for reference, but the y equals 1.5 to the x graph will have fundamental points. Well, when x equals 0, y is going to still be 1, so we have 0, 1. And when x equals 1, 1.5 to the 1 is 1.5, so we're going to have the point 1, 1.5. This contrasts with the points on the y equals 2 to the x graph, which are 0, 1 and 1, 2. Instead of 1, 2, we have 1, 1.5. That's going to give us an exponential function. It's going to have the same basic shape, but it's not going to be as steep as the y equals 2 to the x graph. And we have this comparison. We note that the ratio between the x equals 1 and x equals 0 point is the 1.5. That is, 1.5 to 1 is a ratio of 1.5, and that ratio is the growth factor. So whatever the growth factor is, this point will be that many times higher than this point. Now let's look at the graph of y equals 2 times 1.5 to the x. See if we can position this where we can see it. We can see most of it. In this case, when x equals 0, well, 1.5 to the 0 is still going to be 1. We multiply that by 2 and we get the point 0, 2. If we let x equal 1, we get 1.5 times 2, which is 3, so we have the point 1, 3. Notice that the ratio between the y coordinates here and here is still the same as it was before. That is, the ratio is, in this case, 3 over 2, which is still 1.5, which is still the growth factor. So it seems not to matter what number goes out in front here. The ratio between the x equals 1 and the x equals 0 points is still going to be equal to the growth factor. That's generally going to be true. If we have the function, let's zoom back a little so we can see all of this. If we have the function y equals a times b to the x, the graph of that function is going to have basic points. Well, when x equals 0, we're going to get b to the 0 is 1 times a. We'll have the point 0a. When x is 1, y is going to equal a times b to the 1, which is just a times b. So we have the points, basic points 0a and 1a times b. The ratio between those 2 points is going to be a times b divided by a, which is just b. Now, that, of course, is just the growth factor again, as we've always seen. So, another thing we can notice is that any time x changes by 1, the ratio of y values is still going to be the same. It's still going to be b. And that can be proved in a way that's very similar to the way we proved that the doubling time is independent of where we start.